Hey everyone, welcome back to channel Code with AKJ. Today is day 3 of solving LeetCode 75 challenge, and today's question is kids with the greatest number of candies. So the question says here, there are n kids with candies. You are given an integer array candies where each candies of I represents the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. Return a boolean array result of length n where result of I is true if after giving the ith kid all the extra candies, they will have the greatest number of candies among all the kids, or false otherwise. Note that multiple kids can have the greatest number of candies. So the problem is simple. You are given an array candies where each element represents how many candies a particular kid has, and you're also given an integer extra candies, which is the number of extra candies you can give to any of the kid here. So your task is to return a boolean array where each element indicates if after giving all the extra candies to that particular kid, they will have the greatest number of candies among all the other kids. So multiple kids can have the greatest number of candies after receiving the extra candies. So let's try to understand this particular example. So given candies here are 2, 3, 5, 1 and 3, and extra candies is 3. So this particular kid present at index 0 has 2 candies, kid present at index 1 has 3 candies, and kid present at 2 index is having 5 candies, and so on with 3 and 4 index kids having 1 and 3 candies. We have extra candies 3 here, and we need to assign this particular candy to any of the kids in such a way that that particular kid should have the greatest number of candies when we compare it to the other kids. So the brute force approach is simple. For each kid, you add this extra candy to their current candy count and compare it with the current maximum number of candies in the array. If the new total is greater than or equal to the maximum, we mark it as true. Otherwise, we mark it as false. So for example, here the maximum candies in the given array, which is our current maximum, is 5. Now we'll assign this extra candies value to each and every kid, and we'll calculate the maximum candies. And if in case that current maximum is greater than our maximum value, which is 5 in this case, then we'll assign it as true. Otherwise, we'll assign it as false. So let's quickly try run it. So for suppose if we assign this particular extra candy to the first kid having 2 candies initially, so the value would be 5, and since 5 is greater than or equal to 5, then we can mark it as 2 as it is the maximum value. And when we assign this particular extra candy to the first kid, the value would be 6, which is obviously greater than 5, so we'll mark it as true. So now let's consider the kid present at index 2 having 5 candies initially. So if we add this extra candies to its count, the value would be 8, which is obviously greater than 5, so we'll mark it as true. And next kid having 1 candy, and if we give this extra candies to it, the count would be 4, which is less than the maximum candies in the array, so we'll mark it as false, as this kid cannot have the greatest number of candies if we assign this extra candy to its count. And coming to the last kid having candies 6, and if we assign this extra candies to him, then the total count would be 6, which is obviously greater than 5, so we'll mark it as true. So in this case, our answer would be true, 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 false and true. So we need to return this boolean array in our output. So let's quickly try run this another example, and we'll move on to the code. So here the values are 4, 2, 1, 1, 2, 4, 2, 1, 1, 2, and extra candies given here is 1, and extra candies is 1. So let's again quickly try run this. So here the maximum initially candies are 4. So let's again quickly assign these extra candies to each one of the particular kid, and we'll compare it with our initial maximum candies. So if we assign this extra candies to this first kid, the answer would be 5, which is greater than 4, so we'll mark it as true here. So if we assign one candy to this second kid having two candies initially, the answer would be 3, which is less than 4. So we'll assign false here. And coming to the next 2, 3 kids, if we assign this value 1, which is our extra candies, to their initial number of candies, the current sum would be 2, 2 and 3, which is obviously less than 4, so we'll assign false here. So in this example and in this case, our Boolean array would consist of true, false, false and false. So this was our approach, and here the time complexity would be O of n as we are iterating over a single array, and space complexity would be O of 1 as we are not using any data structure. So let's move on to the code here. So let's start the code. So initial step here would be to find the maximum candies in our array. So we'll iterate over the array candies of size n, and we'll find out the maximum candy. So if current candies of I is greater than max candies, we'll assign our max candies variable with the current value. So in this way, we'll iterate over the whole candies array and we'll find out the maximum candies. We'll also assign a vector of bool result array to store all our answers, and step 3 would be to iterate over the candies array, and we'll assign each candy with our extra candies and compare it with the R max candies. So if it is greater, then we'll push back as true in our resultant array, or else we'll push back false as an answer. And finally, we'll return our result array. So let's compile and run this. It's working, so let's submit. As you can see, it got successfully accepted. So this was the approach we have taken as a brute force. So coming to the optimal solution, here since the brute force solution we just saw is actually pretty efficient. In fact, it's already optimal because there is no unnecessary recomputation. So however, we can break down how we arrived at the solution to reinforce our understanding. Here our key observation would be to first calculate the maximum number of candies that any current kid has. And we can do this using our max element function, which is already present in our C++ STL. And then for each kid, we check if the current candies plus extra candies is greater than or equal to the maximum value. So we can reduce the number of lines of code, but the time complexity and space complexity remains same. So let's try to again refactor this code and reduce our number of lines of code for this particular problem. So here we can find our max candies using a inbuilt function present in our C++ STL, and we'll take our result vector, which is of type bool, and our final result would be to compare by assigning each and every kid the extra candies with our max candies, and finally we'll return our result array. So let's run this code and submit it. So since the time complexity and space complexity remains same, but here we just refactored our code by reducing our number of lines of code. So that's it guys for this video. In this video we have solved the problem kids with the greatest number of candies using both a brute force approach and what we identify as the optimal solution. It's a sample problem but teaches us the importance of finding the maximum and performing comparisons efficiently. So if you found this video helpful, please give it a thumbs up, subscribe to the channel and hit the notification bell to stay updated with more problem solving content like this. Thanks for watching and I'll see you in the next video.